Page 85. A 30-foot crane arm is lifting a load at an angle of 40 degrees above the horizontal. How high is the load above the base? So the horizontal is also the base. And we're looking for this distance. How high is that load? That's up here. How high is it? What is its altitude or its height? That's what we want to know. So the hypotenuse is the crane arm. The opposite is the load height. And the adjacent is the horizontal base. We know H. We want to know O. And we know theta. So we want the relationship of H and O, and that is the sine ratio. Sine of 40 equals opposite, that's the load height, over hypotenuse, which is 30. And this time we're going to multiply both sides by 30. Cancel here. And so that height is going to be 30 times the sine of 40 equals about 19.28 feet. A car is driving up a hill with a 6-degree incline. So here's the car. It's going up this hill. How much height does the car gain after traveling 500 feet? So my question to you is, where does the 500 go? Is it the adjacent or is it the hypotenuse? And this is why a scaffold is very important. Where's the car in this picture? Is it on the yellow track or the pink track? And it's on the yellow track. So the hill is 500 feet. This would just be the ground. And we want to know the altitude the car gains by traveling 500 feet. How much higher is it at the end of that 500 feet? So hypotenuse is 500. Opposite is what we're looking for. Adjacent doesn't matter this time, and we have a theta of 6 degrees. So I want the ratio that gives me H and O in the same ratio, and that is sine. So the sine of theta is opposite, which is the height, the altitude, over the hypotenuse. And to solve this one, we're going to need to get rid of that 500. Have to do the same thing always to both sides. So height is about 500 times sine of 6. Height is about 52.26 feet. And let me put in the steps for you. That was all clear. 500 times 6 sine equals. A person 6 feet tall. Remember, height is always measured straight, perpendicular to the surface, casts a 10-foot shadow. What is the angle of the elevation of the sun? So this time we need to find theta. That's our question mark. Let me go ahead and color. We don't know hypotenuse, nor do we need it. We know adjacent, and we know opposite. So opposite is 6, adjacent is 10. So which of our ratios deals with O and A? Well, that is tangent. Tangent is opposite over adjacent. So tangent of theta, remember we don't know theta. We know opposite and we know adjacent. Now, this is one of those problems like we talked about back on page 8, where you have to use the reciprocal, sorry, not the reciprocal, the inverse to find theta. Anytime you're looking for theta, you need an inverse. And an inverse looks like this. Let me change colors so you can see. Tan minus 1, that's the inverse of tangent. Negative 1, that's telling me that we're dealing with an inverse. Theta is going to be the inverse of tangent times that 6 over 10. And I'm running this all together. Let me scoot this over just a little bit. So the inverse of tangent, which your calculator will do, that's why we need to see it in this form. That's going to give us theta. So to type this into your calculator, here's what you'll do. All clear, 6 fraction 10. And you know what? Let me try something. I'm not sure if that needs to be in parentheses or not. Bear with me just a minute. I should have checked this beforehand. And it does not need to be in parentheses. So 6 fraction 10, shift tan. And if you look above the tan key, you'll see that inverse, tan to the negative 1. That's the inverse key. You get to that by hitting shift. And then you will have to press equals. So let's put it in there. All clear, 6 ABC 10, shift tan equals about 30.96, and it's not feet because we're looking for theta. It's going to be degrees. So anytime that you are looking for theta, you will have to use an inverse function. I don't think it's going to happen a lot, but if it does, you can come back and see this example. And this was just another calculator key. Okay, a rocket is launched. Now, when you launch a rocket, visualize that in your head. In this picture, where is the rocket launch? It's going to go straight up. So here's the rocket, and it's going to launch straight up. It's going to go this way. It is observed. So someone's over here watching from a point That's a 75-degree angle, and it's 1,000 feet away. How high is the rocket? So we want to know the altitude of the rocket. We're looking for its altitude at that point. So let's put in the pieces. This is opposite theta. Everything revolves around theta. Hypotenuse is the line of sight of this observer, which doesn't matter in this problem. We don't care about that. We know that adjacent is 1,000 feet. We want to know the altitude of the rocket, and we know theta this time. So I want a ratio that will put O and A in the same ratio, and that's going to be TOA. The tangent of 75 is going to be opposite, which we don't know. I'm going to call that altitude, over the adjacent side, which is 1,000. And then we will multiply both sides by 1,000 using that reciprocal to cancel. So the altitude is going to be 1,000 times 75 tan equals 1,000 times 75 tan equals about 3,732 feet. I will round to the hundredths, but you could just as easily, a distance that big, you could go to the whole number and be just fine. The smaller the distance gets, the more important rounding becomes. But with an altitude that high, 5/100ths of a foot is not going to make that much difference. But you can do it however you want to. That is the height, the altitude of that rocket.